I want to do another example of 80 using a different equation. And the reason why I'm using a different equation is because continuously and daily, in some circumstances, is nearly interchangeable. However, there are going to be other situations in which daily and continuous is going to be very different, such as this monthly stuff and quarterly and yearly. Therefore, I'm going to show you the more generic equation than APERT. So in this case, it says you deposit $2,500 into an account. So that's going to be your principal that pays 3.5 interest rate. And that's going to go right there where the R is. It's compound daily. So this N here is the number of times within a year. So that daily is going to be 365, which is the same as 365 here. And to get a balance of 3,000, that goes there. And then what is your unknown? And that's going to be how long? T. So bringing the equation over here, we have 3,000 equals, and we have 2,500. 1 plus your rate, which is 0.035 over 365, which is the number of times it happens in a year, and times 365 times your unknown T. And of course, T is what we're going for here. All right, let's do some simple stuff. Always do what you can do, and we can kill some zeros here. I have reducing both of these by 5. 5 goes in here 5 times. 5 goes in here 6 times. All right, so we have, and then I'm going to divide out the 5. So I'm skipping a couple steps here. So I'm going to have 6 over 5 equals, and then the 1, because there's a base of 365, I'm going to go 365 plus 0.035 over 365 times 365 times T. Now, we need to get that T out of both sides. We're going to do that by doing the log. So I have log 6 over 5 equals, I'm going to bring the T because we're getting this out of the exponents, the whole reason why we're doing the log. Therefore, T is going to come down times log and 365.035 over 365, parentheses around that, to the 365th power. We're going to divide this entire entity out. So log 365.035 over 365 to the 365th power, etc. Bring it over here. That entire thing cancels. Therefore, log 365.035 over 365 to the 336 power. All of that is going to equal T. Now, this is where a graphing calculator comes in very handy. And you can put that all in your TI. I am using what's called the Desmo Scientific Calculator. So you can put it, just put desmo.com scientific if you want to use it online as well. And you can use all those notations, hit it in, and notice we're getting the same as the previous video. So daily, continuously, interchangeable 5.2 years. That's the same answer as our previous video. Now, that's going to change a little bit for this one. Okay. So we're using the same equation because our number of compoundings are changing here. We have monthly. And so when it's monthly, your n per years is 12 per year. Just kind of keep that in mind. That's what n is, to n per year. Quarterly, your n here will be 4 per year. That's what quarterly means. And of course, yearly just means your n is whatever your number of years are going to be. Okay, so taking a look here, it says we deposit $1,600 in the bank account. So that's going to be your P for this first one. And so that's going to be 1,600 in your bank account. And we are ultimately, how long to reach 2,000? That means your final accounting is going to be 2,000 on this side. And here we are compounding. How long will it take? So ultimately, we are looking for T for all of these. So this first one, it's going to be 1 plus your rate, which is 0.025 over this is going to be 12 times, and this is 12 up here, and then you're going to solve for T, just like the previous one. This one is going to be the same equation, same scenario. So it's 2,000 equals 1,600. 1 plus, except it's 1.75 interest rate. So we go over twice, 1, 2, 0.0175 quarterly. So it's going to be divided by 4. And you're going to have a 4 up here and a T. This one, again, same thing, 2,000 equals 1,600. And 1 plus, and this one is 4%, so 0.04. And annual means your n is 1 here, and a 1 there, and a T. You're going to use logarithms to solve for T for all three.